This is Mr. Hanna, and welcome to What in the Format. Today we're going to go over systems of equations, solving systems of equations using the substitution method. Now, you'll notice if you watched my last video with graphing that I'm using the same equations. Why would I do that? I already know the answer to these. Well, I'd like to see that I can use substitution and get the same answer as I got before. I already know the answer. I'm going to do a different method. Knowing the answer doesn't stop you from following the steps and practicing your method. In fact, maybe this is a good time to explain the answer to a question that you get. It means absolutely nothing. It just doesn't mean anything. Well, you're thinking, Mr. Hanna, isn't that what I'm supposed to be doing? I'm supposed to be solving and getting an answer. Yeah, you are. But the answer itself means nothing. Why? Well, I'm picking these equations. It'd be interesting if you had a teacher check and see if any of your equations even come close to matching these. There's infinite possibilities here. So the answer I get here doesn't mean anything because who knows when you'll ever see it again, if ever. What does matter is how I go through the process to find the answer. So yes, we know the answer. From the previous video, I know the answer to this system of equations is 3, -1. Okay? And so I write 3, -1. Now, if you just write 3, -1 down for a teacher on a test at this point, you're going to lose points. You might even get a 0 on your test because your teacher's going to think you cheated. Oh, I just did it in my head. The teacher's not going to buy that 9 times out of 10. And if you do, are able to do it in your head, the teacher starts throwing stuff at you. Maybe you're a math genius. And the teacher will find that out and move you up. Great. But for most of us, myself included, I wouldn't know the answer just by looking at this. I have to go through the steps. So how do I know the answer on this video? Because I did it on the previous video with graphing. And I'm using the same set of equations. Why? So now I don't have to worry about the answer. I know what's right. I just have to worry about the process so I can see if my process will give me the same answer. That's what I'm focused on. So, process is system of equation substitution. You have to look at your equation and you want to solve one of the equations for a single variable. Either solve this for x or this for x, this for y or that for y. Now normally, when you're looking for that, you're looking for the variable that's by itself. Either has a 1 or -1 in front of it. This one has a -1 in front of it. Perfect. I'm going to take this equation right here and I'm going to solve it for that variable. It could be x. X might be the one with the 1 on it. It doesn't matter which one you solve for. Okay, so I'm going to solve this for y. So I'm going to subtract 2x. Subtract 2x. You'll notice basically I'm just putting it in the slope-intercept form. You could think of it that way. Solving for y, basically. It is the same thing. It's just a different way of thinking about it, I guess, if you want to look at it that way. Because the words are different in your head, so it may seem different, but you're doing the same thing. So y equals 2x minus 7. So now what do I do with that 2x minus 7? Well, that's what y is. Well, look, I got y sitting right here. So I'm going to take this whole thing, and I'm going to substitute it right there. I'm going to put it where the y is. That's the substitution property of equality. If two things are equivalent, you can replace them, one with the other. So this is now 3x plus 3 times what my y is, and my y is now 2x minus 7 equals 6. Now, stuff comes back. I have to do what? Well, I have to simplify this side of the equation. Now, interesting thing, you'll notice how many variables do I have? I have x. It's in 2 places, yes, but it counts as one variable. See, the y is now gone. When I have one variable here, I can solve now. I can't solve this. Well, I guess you could say, yes, you did. You already did, Mr. Hanna. Yeah, okay, you're right. I solved this for y, but I didn't get a number answer, did I? When we solve here, now we're going to get a number answer, and that's the goal. So now we're going to distribute here. So I'm going to take 3 times 2, 3 times -7. So the 3x stays alone right now. So that's going to be what? 6x, 3 times 2, 3 times -7, -21. Watch your signs there. And that's going to equal 6. Okay. Well, I can already see I'm going to add the 21 over. And I can combine 3x plus 6x. I can do that in one step. You can do it in 2 steps if it makes you feel better. Add those together first and then get 9x minus 21 equals 6 and then go from there. I just try to combine as much math as I can just to save myself writing a lot. But again, that's a personal choice. The more you need to write things out, that's fine. If you need to break a problem into 6 steps, somebody else can do it in 3. Don't worry about that. Just do it in the way that you see it best. Okay. Once you practice it and gotten more experienced, you might start to combine steps, but that's again up to you. It's a personal choice. So 21 plus 6, that was 27. See, then I'm going to divide by my 9, and I'm going to get x equals 3, which is what I was supposed to get. See, 3. So now how do I get the y? Well, the easiest way is to take this 3 and plug it right into there. So now I got over here y equals 2, well, x is no longer 3, or x is now 3, so I plug 3 in, minus 7, so then there's your minus 7, and so then I do the math, 6 minus 7, y equals negative 1, and then there's my solution. And usually we write it as a coordinate. Sometimes the teacher will let you do x equals 3, y equals negative 1, circle that. It doesn't matter to me, but it does matter to your teacher, so follow your teacher. If your teacher wants you to write it as a coordinate, write it as a coordinate. If your teacher wants x equals 3 and y equals negative 1, then just go ahead and do that. But you'll notice I got the same answer as last time. So whether I graph it or do substitution, you're going to get the same answer, but the process is different, or kind of different. On graphing, I had to put this into slope-intercept form. The difference is here, instead of also putting this to slope-intercept form in graphing, I then just took what I got here, substituted in for the y up here, solve for x, plug that x value back into this equation, solve for y. And this is the one I would recommend. You could have done that up here, but that's a little bit more work. I mean, 3 times 3, 9. Subtract the 9, 6 minus 9 is negative 3. Negative 3 divided by 3, there's your y is negative 1. But I usually find plugging into the one that's always y equals. But again, personal choice. Since it works both ways, just take your pick. Plug in into either one. Once you get x is 3, plug into either one of these and solve for y. And there you go. And now we have two ways of solving. We had graphing, we had substitution. So there'll be one more video where we solve by the elimination or substitution method. Again, the answer will be the same because I'm going to use the same equations, but the process will be different. And hopefully you'll start to see some similarities, some connectivity. You'll know that you're getting the right answer. But again, the answer itself is meaningless. Yes, we want to get the right answer, but it's how we get the right answer that's very important. It's how you learn to think through these. Can you see the steps? Can you see how to do these? If you can't, rewatch the videos, take some notes. You got a teacher, ask your teacher, say, hey, I was doing this problem. I don't understand how to do this, okay? Yeah, maybe you're not studying that today in your math class, but teachers love it when students come up and ask them questions. And if it's time when the teacher's not busy and there's like maybe some free time in class, the teacher's, letting the class work on some stuff and you've got your classwork done, that's a great time to go ask the teacher a question. And then if the teacher knows you're done and knows you're trying to learn something, most teachers love to see that because they see then an active mind trying to learn. And that's what teachers want. They just want to teach. They just want kids to learn. If kids aren't learning, if they can't teach, oh boy, being a teacher is the worst thing in the world because we're not there for ourselves. I'm not there for me. I already know all this stuff. I'm doing these videos not for me. I'm doing them because I want to show people what my teachers taught me. This is what my teachers taught me. They taught me how to take it a step at a time, how to see things. Don't go fast. You don't need to know the answer before you start the problem. You just go through the process. You memorize your process. You trust it. Boom. Doesn't matter what I throw up here. I can find it now. And that's what I want for you. That's what I want for students who are learning math. And I want them to gain that confidence. Why? Because problem solving is a part of life. It doesn't matter whether it's a math problem or a science problem. The way you learn to solve problems is what you're going to do the rest of your life. If you learn to solve problems now, you've got the advantage when you get a job and have to solve different problems because you won't be afraid of solving problems. And you'll find yourself coming up with innovative solutions and impressing your boss and moving up and being confident and gaining status in your job. Whereas those who don't know what to do and always have to be told what to do and can't remember what to do, they don't stay around very long. Not a very good situation to get fired. Not fun at all. Anyway, hopefully, that's a little bit of a tangent there, but you start to see what these videos are for. Break things down to steps. Learn how to think. That's what they're there for. Okay? Ask questions when you need help. Ask questions. Get help. Watch the videos again. Don't think you have to get it right away. Anyway, this has been Systems of Equations, Solving by Substitution. It's been Mr. Hanworth with the format. Thank you for watching. Happy mathing.